Okay, we're going to wrap up Unit 4, Lesson 10, and we are going to talk about graphs and the coordinate plane. So the first thing you may be asking is, what the heck is a coordinate plane? Well, it's very simple. It's this big grid right here. On this grid, you have been graphing lines. So as you can see in this picture over here, I have this lovely purple line, and then I have 3 dots. One in red, one in purple, and one in green. And that's because we want you to understand this one last concept of a graph. When you graph, you be in one of 3 places. Wow, that's not great English. But you can be in one of 3 places. Your dots can be on the line. You can be above the line. Or you can be below the line. Now, you may be looking at that saying, well, that red dot doesn't really look like it's above the line, Mrs. Trulin. It looks like it's to the left of the line. And the green dot looks like it's to the right. Well, you can say to the left and to the right, above and below, but I just want you to realize that a graph, this line, divides this coordinate plane into 3 places. You have one side, the other side, or you can be on the line. So for example, this point right here, which is 0, -2, is an answer to the equation of the line that I have here. See, the equation of the line is y equals 4x minus 2. We can see that. We have a y-intercept of -2. We have a slope of up 4, 1, 2, 3, 4 over 1. And if we were to put that point into the equation, we would get a true value. Does -2 equal 0 minus 2? Why, yes, it is. And so will any other point that I pick that's on the line. Now let's see what happens when we put this red coordinate into our equation. So that is the coordinate -6, 7. So into this, the y value is 7. The x value is -6. -24 minus 2 is -26, and voila, you can see that the red dot does not return a true statement, so the red dot obviously is not on the line. In fact, what you kind of saw here was that this y value ended up being greater than 4 times the x value minus 2. Now, this is what we're going to do in Chapter 5. Don't need to worry about it today, but I just thought I'd point it out. So here is the green dot, 9, -1, and I'm going to put that coordinate into my equation. Y value is -1. X value is 9, which has to get multiplied by 4, minus 2. Get -1 equals 36 minus 2. -1 equals 34? No. But you can see here that this one was where the y value was less than 4 times the x value minus 2. And once again, something we will do in Chapter 5, but notice what we had was the line was equal, this side was greater than, and this side was less than. Makes sense. All right, so basically all we're going to want you to do is to be able to graph lines and tell me points on the line work in the equation, points not on the line don't work in the equation. So we're just going to do a real quick review here. Could you graph this line? Could you realize that you need to get the y value alone? So the first thing you would do was set about getting the y value alone. Realizing that the y value is not quite alone yet, so I have to multiply everybody by the reciprocal of -2 to get rid of this -1/2. I'm going to do a little canceling here. -2, and that 4 can cancel down to 2, so that will be +3/2. And then -2 times 4 is -8. And there I have it. I can graph my line. -8, up 3, 1, 2, 3 over 2, up 3, 1, 2, 3 over 2, up 3, 1, 2, 3 over 2, and I have more than enough points now to draw my straight line. All right, so if I were to take this snowflake and it were to gently fall, and let's see where it stops. Obviously, we could say that this point is not on the line, and therefore if we were to take the coordinates of this point, which are -1, -1, it would return a false value. 3/4 of -1 minus 1/2 of -1. Is that going to get me 4? Well, -3/4 plus 1/2. Does that get me 4? No, of course not. It's not on the line. But if this snowflake were to gently fall on the line, it would return a true value. All right, simple as that. See you tomorrow.